After understanding how the remodelers approach the house, we can now evaluate it in terms of how effective their choices are within the context of the environment. We will determine how the house ranks in terms of its health, energy efficiency, resource efficiency, and the remodeling company's overall environmental responsibility. The experts come from all corners of the building and remodeling trade. Cecil Smith builds homes for chemically sensitive people. Mike O'Brien consults with contractors. Marcus Stoffel provides earth-friendly building products. Greg Aker designs environmentally sensitive homes. Along with providing factual information to the experts, we've collaborated on special tests and measurements to the best of our ability. We begin in the living room.
Our first category is healthier. We all want our personal environment to be safe and healthy. Cecil, what exactly is healthy?
Healthier.
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 Oh, there's a difference.
There's a big difference. To be healthier, you eliminate or you cut down the amount of unhealthy problems or chemicals or whatever you're dealing with in a home. Your floor covering, which contains 0.25%, your walls and your ceiling contain the rest of the surface area of a home. So if you have a product in the floor that's off-gassing, like carpet, for example, you can have up to as many as 88 toxic chemicals in the manufacturing process of that, whether it be in the dyes or in the glues or whatever. Even if you have cotton carpet, you can take and add pesticides in the growing process of the carpet, which makes it no longer healthy. The wool comes from overseas. The wool can be processed and sprayed with pesticides.
In this house, about 20% of the total floor space is covered with carpet. It's made of wool from New Zealand, and it contains all-natural, low-toxic fibers.
How does a person that's doing their house even start this process?
It's very difficult. You start with by not using carpet, and then you start with by researching and looking for books in the local bookstore on healthier products.
There's actually a lot of resources out there if you're aware of them. You can get materials from the American Lung Association, you can get materials from the EPA. As Cecil said, there's a lot of books on designing and building a house that's healthier. And we've been using them in a remodel that we're doing now. We're out there looking for the materials that are really pretty and they go well together, all the things that people are usually doing, but we're also trying to select things that aren't going to introduce pollutants into the house. We're going to use a floor in our house that doesn't have to have a toxic floor finish applied to it to look good. Another one would be the cabinets in the house here are built with medium density fiberboard that doesn't give off formaldehyde instead of the standard particle board that does.
It's not made with it.
There isn't any formaldehyde in the fiberboard to start with. Those are examples where you can have the thing that you want for the appearance that you want, but you can have a safe material.
The exterior decks utilize pressure-treated wood instead of cedar. This presents a potential health risk because of a potent chemical used in the treatment process. Chromated copper arsenate, also known as CCA, even with minimal exposure can cause skin irritation. It's also difficult to dispose of because it's considered toxic waste. The remodelers, however, did take precautions with the deck surfaces. Here they applied a natural preservative that seals in the toxins, protecting those who come in contact with it. If you're concerned about how building materials could create problems for you, ask your supplier for information.
There's a material safety data sheet that's usually available to all building materials that are on the market, but that doesn't always tell you exactly what the health effects are of certain chemicals that are in the materials.
I think another aspect that's really important in the environment is not only physical health but mental health. And in my practice as an architect over many years, we found that our clients really enjoy bringing daylight into buildings. It makes it a much more cheerful environment. This house is a good example, actually, of bringing daylight in and increasing the natural lighting rather than relying on artificial lighting, which also uses more energy.
Energy efficiency equates to using a minimum amount of a natural resource, energy, while yielding the maximum amount of benefit. Mike, since this is a luxury house, why should they worry about energy efficiency?
Yeah, that's a good question. The family that buys this house obviously can afford to pay for the energy, so they don't really need to be concerned about that. But they might pay all the energy bills for the house and still end up being very uncomfortable. And what you want to think is that what you're really buying with that energy is that you control the weather inside your house. You get to set the comfort at what you want. If the house has a lot of air leaks in it, then when they're running their furnaces in the wintertime, that's going to make the house seem too dry. They're going to have the comfort, dry skin problems, dry eyes, all that. because the air leaks are letting the air leak out of the house as fast as it's being warmed, and the dry air is coming in to replace it. So we want to tighten that house down in order to make it more comfortable.
To a point.
We also want to tighten the house for Cecil so that he can put his ventilation system in and it'll work effectively.
How tight is too tight, though?
We want to get it down tight enough that we can pull in fresh air, run it through some filters to clean it, and deliver it into the house. And when we're running those fans, we're not pulling air in from under the sink or something like that.
Now, contractors, though, they say, you know, I purposely build a house that's not too tight.
Well, they don't know. That's the problem with that statement. They don't know how tight or how loose the house is. This house is a good example. There's a tool called a blower door where we can measure how tight the house is that most builders don't use. But we did use it on this house.
The blower door screen covers a door with a fan that draws the air out of a closed house at a measured rate. The test can also help identify specific leaks using a smoke-emitting device.
If we were talking about a tight house, we would have given it a rating of 1. If we were talking about an average house, averagely leaky house, we would have given it a rating of about 3 or 4. This house we gave a rating of over 10.
This means if we could add up all the cracks that allow air to pass through the walls. In this house, it's like having a 3 by 3 foot hole open all the time.
That means it has a lot of air
Very
leakage in
loose.
it, and there's going to be some comfort problems if those aren't fixed. If it does turn out that the house is too loose, we can fix that. And we can get it down to the target tightness that we want to make our ventilation system work correctly.
And the ventilation system consists of 3 gas furnaces and 3 electric heat pumps. For heat, air conditioning, and hot water, we've calculated that a family of 4 will pay around $1,800 per year. This is double what they would pay with the most efficient heating and cooling system available today.
Marcus, can you talk a little bit about embodied energy?
Basically, you look at the energy that goes into producing something from a raw material like wood, which is essentially just cut down from a tree and milled. It uses very little energy, whereas like concrete or steel, it's mined from the earth, it's heated and treated, and it uses a lot of energy. So in that way, you can assess how much energy is being used for different materials.
So this house took an old house that had embodied energy in it.
If you prolong the life of a material, that way you're using the resources more effectively, obviously.
Also, as architects and builders, we don't like to think about it too much, but all buildings do have to be demolished at some point. So we want to use as many materials that can be recycled at that point, too, to keep that embodied energy in the cycle. Another part of the picture, this house happens to be oriented to the southwest, so it gains a lot of passive solar gain in the wintertime, and they've also controlled overheating in the summer with some projecting balconies and ways to shade the glass when the summer sun is high.